This video focuses on mixed numbers as part of the arithmetic readiness unit of beginning algebra. Mixed numbers has 13 topics with timestamps in the description. Let's begin. Writing an improper fraction as a mixed number. In this example, we're writing 17/5 as a mixed number, and notice that we are starting with an improper fraction where the numerator 17 is larger than the denominator 5. And our process for turning an improper fraction into a mixed number is to divide the denominator, which here is 5, into the larger numerator, which here is 17. And when we do this division, we can see that 5 goes into 17 3 times. 3 times 5 is 15, and our remainder is 2. This remainder becomes the numerator of our mixed number, and the denominator will stay the same. It's still 5. So 5 goes into 17 3 times with a remainder of 2. The remainder is still over the denominator of 5. Rewriting 17/5 as a mixed number, we have 3 2/5. Writing a mixed number as an improper fraction. In this example, we're writing 3 1/6, which is a mixed number, as an improper fraction. And our process for turning a mixed number into an improper fraction is to multiply the denominator with the whole number, then add the numerator. This will give us our new numerator, and we will keep the denominator. We would multiply the 3 and the 6, giving me 18, and then add the 1 to get our new numerator, 19, and then keep that denominator of 6. So as an improper fraction, we have 19/6. Mixed number addition with the same denominator and renaming. In this example, we're asked to add these two mixed numbers and to write our answer in simplest form. And to start, I'll write the addition vertically. And from here, I know that I can add the whole number portion. 1 plus 8 gives us a 9. And then I can add the fraction portion. And since the denominators are the same, they're both 8, I know that I would keep the denominator, 8, and add the numerators. 3 plus 7 would be 10. And from here, I notice two things. First, that the fraction 10/8 can be reduced because both 10 and 8 are divisible by 2. 2 goes into 8 4 times, and 2 goes into 10 5 times. And just with that simplification, I now have 9 5/4. But I also notice that 5/4 is improper. The numerator is bigger than the denominator. And I know that to make an improper fraction into a mixed number, I can divide the denominator, 4, into the numerator, 5. 4 goes into 5 once. 1 times 4 is 4. So our remainder is 1, and the denominator stays the same, 4. So we now have the whole number 9, and the 5/4 is 1 1/4. The two whole numbers there, 9 and 1, will need to be added together. 9 plus 1 is 10, and the fractional part, this is in simplest form, so this would be our final answer. Mixed number subtraction with the same denominator and renaming. We're asked to subtract, and when we rewrite this subtraction vertically to line up the whole number portion and the fraction portion, I see that the 7 is missing the fraction portion. It's just a whole number. So to do the subtraction, I'll want to rewrite this problem and use the fact that 7 can be written as 6 plus 1. So as a mixed fraction, it would be 6, and the 1 could be written as 5/5. And I chose 5/5 so that the denominators will be the same, allowing me to subtract the fractions. And in effect, I have borrowed 1 from the 7 and just written that 1 as 5/5. And from here, I can subtract, starting on the right, 5/5 minus 4/5. The common denominator is 5, and 5 minus 4 is 1. Then, looking at the whole numbers, 6 minus 3 is just 3. And this mixed number is in its simplest form, so 3 1/5 is our solution. Addition or subtraction of mixed numbers with different denominators without renaming. In this example, we have 7 5/9 minus 3 1/6. And I'll start by writing this vertically. And the first thing I notice is that I have different denominators. So I'll need to identify the lowest common denominator between those two fractions. And between 9 and 16, the lowest common denominator is 18. So I will want to rewrite these fractions with that common denominator of 18. So in the top, I would need to multiply the 9 by 2, meaning I also multiply the 5 by 2, giving me 10 over 18. And then in the second fraction, I would need to multiply the 6 by 3 to get 18. Multiplying the numerator by 3, I would have 3/18. And now that I have common denominators, I can subtract, starting with the fractions. I would keep that denominator of 18, and 10 minus 3 is 7. And for the whole numbers, 7 minus 3 is 4. This is in simplest form. Since I can't reduce the fraction, our answer is 4 7/18. Addition of mixed numbers with different denominators and renaming. We're asked to add these two mixed numbers, and I'll start by writing the addition vertically. And I know that in order to add the fractions, I'll need a common denominator, and the lowest common denominator between 2 and 5 would be 10. So I know that I'll be rewriting with a common denominator of 10, and starting with the top, I would need to multiply this 2 by 5 to get 10. Multiplying the numerator by 5 gives me 1 times 5 is 5. And then in the bottom, I would need to multiply the 5 by 2. Multiplying the numerator by 2 gives me 6. And now that I have a common denominator, I can add the fractions, keeping the denominator. Adding the numerators, 5 plus 6 would be 11. And then adding the whole number portion, 3 plus 7 is 10. However, this mixed number has an improper fraction. So rewriting once again, we have the whole number 10, but the improper fraction, 10 goes into 11 one time with a remainder of 1, so 1 1/10. From here I can see that I have whole numbers of 10 and 1, giving me 11, and the fraction of 1/10. This is in simplest form, so this would be our final solution. Subtraction of mixed numbers with different denominators and renaming. We're asked to subtract these two mixed numbers, and writing the subtraction vertically, I see that for the fractions, we have different denominators, so I will need to find the lowest common denominator, and between 4 and 10, the smallest number divisible by both is 20. So I'll rewrite the problem with the common denominator of 20. In the first mixed number, I would need to multiply the denominator by 5 to get 20. So I would also multiply the numerator by 5. And then for the second mixed number, I would need to multiply by 2 and also the numerator by 2. So we now have a common denominator. However, my numerators, I can see that I would have 5 minus 6. So I will need to borrow. And borrowing from the 7 would leave me a 6. I could then add that 1 to the fraction. And since I need common denominators to add, I would write that 1 as 20 over 20. So I borrowed 1 from the 7, making it a 6, and added that 1 to the fraction. And I now have 25 in the numerator, and I still have 20 for the denominator. And from here, I can now subtract. For the fractions, I have a common denominator of 20, and 25 minus 6 is 19. And then for the whole numbers, 6 minus 4 is 2. 2 and 19/20 is in simplest form, so this is our final answer. Word problem involving addition or subtraction of mixed numbers with different denominators. In this example, we're told that Chow jogs 2¼ miles from his house. He then jogs 3/8 miles farther, and we're asked how many miles he jogs in all. And we know from the description that we'll be using either addition or subtraction here, and the key word is farther. Originally, he jogged 2¼ miles, then 3/8 of a mile farther. This tells us we'll be using addition. Aligning the two numbers vertically, I notice that I have different denominators, so I will need to identify the lowest common denominator. And for 4 and 8, 8 is the smallest number that's divisible by both 4 and 8. So I'll be rewriting here to get that common denominator of 8. And in the first number, I'll need to multiply the denominator by 2. So I'll need to multiply the numerator by 2. And then the second number, I already have a denominator of 8, so nothing needs to be changed. And from here, I can add, starting with the fractions. 2/8 plus 3/8 has a common denominator of 8, and 2 plus 3 is 5. Then for the whole numbers, 2 plus 0 is 2. The 5/8 is in simplest form. Looking back at the question, we were asked how many miles, so our solution is 2 5/8 miles. Mixed number multiplication. We're asked to multiply these two mixed numbers and to write our answer as a mixed number in simplest form. And to multiply mixed numbers, our first step will always be to turn those mixed numbers into improper fractions. So rewriting each of these as an improper fraction, I would start by multiplying the 2 and the 5 to get 10, and then adding the 1 gives me my numerator, 11, and the denominator would stay the same, 5. Then converting the second mixed number to improper, 4 times 9 is 36, plus the 4 on top gives me 40, and the denominator here is still 9. So we have rewritten mixed number multiplication as improper fraction multiplication. But from here we can use all of the tools of regular fraction multiplication, including cross-canceling. And when I look at this 5 and 40, I can see that they're both divisible by 5. 5 goes into 5 once, 5 goes into 40 8 times. And from here, multiplying the numerators, 11 times 8 is 88. multiplying the denominators, 1 times 9 is 9. And looking back at the instructions, we were asked to write the answer as a mixed number instead of the improper fraction that I currently have. I can convert by dividing the 9 into 88. 9 goes into 88 9 times. 9 times 9 is 81, leaving a remainder of 7. That remainder is our numerator, and the denominator is still 9. The mixed number is in its simplest form, so 9 and 7/9 is our solution. Multiplication of a mixed number and a whole number. In this example, we're multiplying 3 and 5/6 and 9, and we will write the answer as a mixed number in simplest form. And I'll start by recognizing that whenever I have mixed numbers being multiplied, my first step will always be to turn those mixed numbers into improper fractions by multiplying the whole number part and the denominator. 3 times 6 is 18, and then adding the numerator. 18 plus 5 is 23, and the denominator is still 6. And since I'm multiplying by 9, I can rewrite the 9 as a fraction as just 9 over 1. From here, I now just have fraction multiplication, and I can use all of the tools of fraction multiplication, including cross-canceling, and I see that the 6 and 9 are both divisible by 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. And with no further cross-canceling, I can multiply across the numerator. 23 times 3 is 69. 2 times 1 is 2. And this is where I look back at our instructions. Instead of the improper fraction that I have here, I was told to leave my answer as a mixed number. So dividing 2 into 69, 2 goes into 6 3 times with no remainder, bringing down the 9. 2 goes into 9 4 times. 4 times 2 is 8, and we have a remainder of 1. That remainder becomes our numerator. The denominator is still 2. Our mixed number is in simplest form, so this is our final solution. Division with a mixed number and a whole number. We're given this example asked to divide and to write our answer as a fraction or mixed number in simplest form. And to do mixed number division, we will first rewrite any mixed numbers as fractions, and I'll also write any whole numbers as fractions. So 15 would be written as 15 over 1 divided by rewriting the mixed number as an improper fraction. We would multiply 2 and 7 to get 14, and then add the numerator 6. This would give me 20, and the denominator would still be 7. And you can see here that we've rewritten this in such a way that we have division of two fractions. And our process for dividing fractions is to leave that first fraction as it is, 15 over 1, turn the division into multiplication, and then take the reciprocal of the second fraction. So moving the 7 to the numerator and the 20 to the denominator, we now have fraction multiplication. And fraction multiplication means we can cross-cancel if possible. Here the 15 and 20 are both divisible by 5. 20 divided by 5 is 4. 15 divided by 5, 3. And now that we've done any of the cross-canceling that's available, to multiply fractions, we multiply the numerators. 3 times 7 is 21. That's our new numerator. And then we multiply denominators. 1 times 4 is 4. That's our new denominator. And since this is an improper fraction, we prefer mixed numbers, so I will divide that denominator into the numerator 21. 4 goes into 21 5 times. 5 times 4 is 20, leaving a remainder of 1. This 1 becomes our numerator, and the denominator is still 4. This mixed number is in simplest form, so 5 1/4 is our solution. Mixed number division. We're asked to divide here and leave our answer as a fraction or mixed number in simplest form. And I'll start by recalling that multiplication and division of mixed numbers is done by first converting those mixed numbers into improper fractions. So the 4 3/4 would need to be converted. I would do so by multiplying the 4 out front and the 4 denominator to be 16, and then adding the numerator 3, giving me 19 with that same denominator 4. And our second number here is just a fraction. It's not a mixed number, so there's no need to change it. It is just the fraction 5/6. And now that I have fraction division, I know that to do fraction division, I leave that first fraction as is. I convert division into multiplication by taking the reciprocal of the second fraction. So 5/6 has the 6 move to the numerator and the 5 move to the denominator. And from here I just have fraction multiplication. And fraction multiplication means I can cross cancel if possible. Here the 4 and the 6 are both divisible by 2. And dividing by 2, I would have 6 divided by 2 is 3. 4 divided by 2 is 2. And now I can multiply the numerators to get 19 times 3 is 57. And I can multiply the denominators. 2 times 5 is 10. And since 57 over 10 is an improper fraction, I'll convert that to a mixed number by dividing 10 into 57. 10 goes into 57 5 times. 5 times 10, 50, leaves me a remainder of 7. That remainder is my numerator. The denominator is still 10. So as a simplified mixed number, we have 5 7/10. Word problem involving multiplication or division with mixed numbers. In this example, we're told that a shipment of 10 tons of sugar is separated into containers of equal size, and that the shipment fills 6 3/7 containers. And our question is, how much sugar can one container hold? So notice that we are starting with that 10 tons of sugar, and we are separating it or dividing it into equal size containers, meaning we start with 10 tons and we divide that 10 tons into 6 3/7 containers. So this example has us using division. And since we have mixed numbers, we know we will start by rewriting whole numbers and mixed numbers as fractions. So 10 can be written as 10 over 1, and 6 3/7 as an improper, we would multiply 6 and 7 to get 42, add the 3 to get 45, and keep the denominator of 7. So we now have fraction division, and fraction division is converted into multiplication by keeping the first fraction the same, turning division into multiplication, and taking the reciprocal of the second fraction. So moving the 7 from the denominator into the numerator, and the 45 from the numerator into the denominator. So we've had two steps here, rewriting as fractions and then turning division into multiplication. But from here, fraction multiplication says we can cross cancel if possible, and both 10 and 45 are divisible by 5. 10 divided by 5 is 2. 45 divided by 5 is 9. And with cross canceling complete, we can multiply the numerators. 2 times 7 is 14. And we can multiply the denominators. 1 times 9 is 9. 14/9 is improper, and we were asked to write our answer as a mixed number in simplest form. So converting, we would divide 9 into 14. 9 goes into 14 once. 1 times 9, a 9, giving me a remainder of 5. This remainder is our numerator, and the denominator is still 9. 5/9 doesn't simplify. And looking back at our question, we were asked how much sugar can one container hold. The units here for the sugar is tons. So we would have 1 and 5/9 tons in each container.